I'm very good. Thank you, Yaz, for having me. It's a pleasure to talk to you all today.
Ex Excellent. Excellent. Thank you so much for joining us. And you are going to talk to us about end user monitoring in production,
That is correct.
um, which is useful for all kinds of things, especially when you're testing in production. Um, and we will start you off in just a moment. Just a reminder that Zach will be presenting for roughly how long? About 15, 20 minutes, something like that.
Yeah, just about. Yep.
Just about. And we have these Twitch chat live, and myself and Kim, our producer, will be fielding questions in the chat, but we'll also be taking questions with Zach after his talk on all matters of testing in production and especially monitoring in production. So I will switch it over to your slides and take it away, Zach.
Great. Thank you. Yeah, and so good day, everyone. Happy Thursday. As Yaz was saying, Zach Henderson here. I'm a solution engineer at Catchpoint. We are a monitoring company. So today's talk is all about end user monitoring. So the idea of this group, testing in production, there's a whole lot of things that go into testing in production. Monitoring is just one key part of that, usually after release or after post-release. This is where you're trying to guarantee that the systems and services that you've built are actually working for the people that you built them for. I know there's a whole lot of things to testing in production, so today's talk is just mostly on that monitoring piece. But if you have any questions about other pieces here or my thoughts on it, happy to kind of talk through at least what I know on those angles as well. And so the general idea of end user monitoring in production is the fact that it is in production. You're essentially monitoring the world, and the world is asking, hey, can you tell me how your real users actually perceive your app or service's performance and its availability? Because if you understand how real users perceive it, it's basically the key to optimizing the right things, finding the right issues to fix, and improving your user experience overall. And so when we say production and monitoring of it, it's kind of a very big world, right? You know, your app that you've developed, you've worked hard on, it will run on thousands of different devices, from smartphones, laptops, TVs, gaming consoles, different websites, web browsers, all those things. And those devices that you're trying to get understanding of are around the globe, in different countries, different regions, all with a different set of capabilities, resources, constraints. And there's a whole variety of the network piece, right? The internet's not just one big network, it's a bunch of little tiny networks talking to each other. And so the idea of, can you monitor that type of interaction for your users? And it's just a lot of variables to consider. So in general, the idea is that those different things all work together for a user. So when you have your app or system that you've developed, you've pushed it in the cloud, maybe multiple clouds, maybe you have multiple data centers, you're co-located somewhere, for example. Your users, want to access those apps. They want to access how you've delivered those apps. And so they'll come from their home, their coffee shops, their offices, their environments, over different browsers, different machines, from anywhere around the globe. And they'll access, things through their last mile network that they pay internet for. And those last mile networks will carry traffic over the backbone of the internet. And they'll talk to your DNS providers, your DNS servers, your content delivery networks, security vendors you have, even third-party services that you integrate with the app. And for a user, they don't just see your app in the cloud or in the data center. They see this whole type of complex user journey, right? And so it's kind of a lot of things to think about. It's kind of overwhelming a lot of times, just thinking, hey, I'm building something. Is it actually going to work for the users? So I need to go ahead and monitor that. And so the idea is that you can actually kind of boil it down to at least 4 general concepts, right? These are kind of pillars, if you think about it, which you can build off of different strategies on for monitoring your end user experience. So the first is availability. Is your application simply up? If it's down, it's going to be down everywhere regardless, right? But then another idea is it reachable? Because your app can be 100% up, but if your users can't get to it, then to them that's down, and the idea that you can't reach it, it's not available for them. So that's a really big concern that people have to think about. And then the idea is reliability. Can they actually trust it? If you're developing something that they need to do the work, that they need to do to see and talk to their friends and family members, all those kind of different things you use the internet for, can they trust it to do what you expect whenever they use it, right? And then finally, the idea of performance. If you're up, you're reachable, and have some trust built into those factors, is it fast enough to do what they need to do? And your app's going to be completely different than someone else's app is developing, but users expect speed, they expect quality of service, and they don't want to have to wait because bad performance is really just a new downtime nowadays. And so the only really way to actually monitor a real user, the actual end users themselves, there's only really two methodologies you can use. Real user monitoring, which is the idea of real-time data captured from those actual visitors to your app or service, and that's the actual user experience being reported back. And the idea of synthetic monitoring, which is real-time data basically captured from robotic users. The idea there is that these two methodologies can really complement each other. So you get a real user understanding of the system, and you get a really proactive, protective understanding of your system from these robotic traffic to your site, for example, or service. And so kind of looking back at those different concepts, right? Availability, that's only going to be basically internal synthetic monitoring. You want to have a robot that's in your data center or your cloud environment that's constantly pinging and probing all the things that you rely on from that area. So you can kind of prove that robot is up and telling you that things are available. And usually you actually kind of want that robot just a little bit outside of some sort of environment that you're hosted in, so you can have out-of-band monitoring on availability. The idea of reachability, all people tend to think it's external synthetic monitoring. Can a robot at 24/7 from different areas around the globe on different networks, last mile backbone, wireless networks, can they actually reach my system, different parts of my system? Actually, there's some technology out there nowadays. We can actually use some supporting RUM data to actually answer this idea of reachability. And then, reliability and performance. Those are both going to be data sets that you can get from synthetic, internal and external, and real user technology as you get traffic visiting your site. So the idea here is that, let's kind of break it down for availability, right? Availability is your application up, and can it respond to requests? Kind of very simple thing, right? So it's basically your app in the cloud or your data center asking, am I up? Am I available? Can I actually do what you've built me to do, right? So essentially, that's just active synthetic probes where you have some sort of robotic agent that's probing different parts of your system and saying, are you up or are you down? And again, it's kind of from those data centers or cloud regions, this idea of availability. If you're down there, then you're going to be down everywhere. So pure availability is mostly just about where you're hosted or where your application is living. And then usually, just kind of a quick example, for like a web app, very popular example, is mostly just getting a HTTP 200 response code from a web server, maybe doing some sort of content validation. That's the majority of what people are doing, where these kind of simple availability checks and say, hey, can this thing actually reply back in a healthy manner? But from your database or for your load balancers or other parts of your system, there may be different types of checks you would do for these kind of health checks of your application. And then the idea is that you do this for both user-facing application, the thing that actually users are accessing, that whole kind of package that you're delivering, but also do it for all your dependent services, because if those dependent services are down, the user would probably see part of their application being down. And to them, it's not going to be a good experience, right? So the system you built has dependent services. Make sure you're monitoring the availability of all those dependent services. And if you're building SLOs, SLAs, SLIs around those uptime of these services, really understand how those are actually kind of rolling up to that user experience, right? This is kind of where you get like SLA calculus a little bit. The idea of, if my database has to be up 99.95% of the time, that means my users may have a bit of a different SLA at 99%, for example. So kind of calculus there is really important. But for most SLAs, SLOs, SLIs, it's purely based on this type of availability. Those are a lot of things that you can typically control in your environment. And so a few things to consider, it's binary in nature. Either you're up or you're down, kind of the general feel there. Each service and dependency will have its own availability, right? But the user is basically asking, hey, is this service available to me? And that's a really critical thing. And then usually, for a lot of people, this is actually the easiest to monitor, understand, and conceptualize. You can really understand if your service is up or down, and you can kind of really get a sense of monitoring that, right? And so in regards to availability, synthetic traffic, that robotic traffic, is really the only way you can actually measure this uptime. If you rely on your users, what you're basically doing is saying you're down when you get a bunch of messages on Twitter, or you get a bunch of calls to your support channels, and you can't really rely on traffic volumes because you have no idea what's causing those dips in traffic. You're only knowing that perhaps your site or service could be down, for example. And then remember, your app can still be 100% available. It can be completely up, but users can still complain about something not working quite right with the app. Hence the idea of reachability, right? So can a user from their home or office traverse the actual internet, their local network, talk to your DNS provider, talk to your CDN provider, any security providers you have, any third-party services you've embedded, and get through all those things to actually access the app you have running in the cloud, in your data center? And so this idea of reachability is a very big concept that a lot of people are trying to get their heads around. How can we make the internet more reliable to guarantee reachability of our services for our customers, right? Because that's the end game. You want to have your app available and reachable to your actual users. And so a few things to consider, right, when you talk about reachability. It's basically, is my origin reachable? Is my DNS server reachable? Is my CDN provider reachable? If none of those services are reachable on the internet, a lot of times you're going to be basically relying on data that's in your application or your code that can't help you answer, is my system reachable, right? And basically the idea is that for reachability, a lot of times network conditions matter. So can you actually see, are you reachable from different ISPs? For example, my reachability to Zoom or Facebook or Amazon from Boston on Comcast is completely different to someone else's reachability when they're coming from San Francisco or Seattle on Verizon or some other last mile providers, right? So where you stand on the internet kind of really changes your view of how things are reachable. And in a general sense too is that not only are you need to monitor the reachability of your code, your systems that you rely on, but third parties as well. So if you rely on data from Facebook, or you rely on ads calls for making your services monetarily worth it for the business, or maybe you have like APIs you rely on to pull data in. If they're not reachable to you, they're essentially down. So really understanding that, because that type of stuff can cascade and impact your actual users. And then a lot of times people tend to think that reachability is something they can't control. Like I can't do anything about Boston and Comcast having an issue. But the idea is that your users, like 95% of your users, don't really know that. They see your site, they see you trying to get your site, and they're going to complain to you that you actually can't reach it. And they're going to say, hey, why can't I get to your service? And they're going to hold you accountable. Because if you think about it, the next thing they're going to do is go to google.com and say, hey, I can get to Google. Everything's fine where I am. But for some reason about your system, they can't actually reach it. And you're basically being compared to the likes of Google, Amazon, Apple, Facebook, for example. And these reachability issues, you can't always fix them, but you'll still be held accountable and have to communicate that. And you're going to be basically wasting time trying to figure out, is it us? Is it the network? Is it some sort of third party that's causing issues for our customers? And usually, it's highly network dependent and infrastructure dependent. So think your DNS resolution issues, think BGP route leaks in the internet, poorly performing internet service providers, all these things that you're trying to work with. If you don't have a handle or visibility into these type of components of your system, they can really cause some issues. But it's not only just the network as well. It can be your application, your infrastructure, your environments you're hosted in, like the firewalls you rely on, the load balancers and things like that. If any of those components aren't working, if essentially your site could be, your app could be 100% running, but users can't actually get to it. And also a really key thing that I mentioned earlier with reachability is that a lot of people think it's only synthetic data that can use this, because you have, like, hey, you have a robot 24/7 reach my service. But there's actually a nice set of work that Google's doing with network error logging, where you can actually tie in your domain and have Chrome actually report back anytime a real user is trying to access your site or service or access your domain, and they get a DNS error, they get a TCP timeout error. So there's actually been a lot of work recently in trying to get real user data coming into your site, your systems, your logging, whatever you're using, to say, can actual users get to my system, right? So is my DNS reachable? Is it failing for real users? Is it closed? Is it TCP drops being aborted and things like that? So we can talk more about this in general, but do think that there is some cool stuff you can do with real user traffic to define, am I reachable out there in the internet? And so once you're available, once you're reachable, you kind of want to answer, am I fast enough for my users? And so that's where performance comes in, one of those other pillars of end user monitoring. And so a general sense here is, first off, what does performance actually mean to your business, to your users? And the metrics you use matter, because those metrics are what you're going to be explaining to your user base about what's going on. And so a lot of people have done work in this, in the environments, to say, hey, what does it actually mean for performance to happen for our users? So you'll see metrics like first paint times, first meaningful paint times, time to interactive, the idea of what a user actually sees when they try to load your site, your service, your system. So these kind of components, these user-centric metrics, are really powerful for you to explain and understand what it actually means for your site or service to be fast for your users. Basically, if you kind of look at it this way, you can say, hey, is my service happening? Is it useful? Is it usable? And then if you take a look at these high-level user-centric KPIs, you can then understand, hey, is it the network? Is it the code? Is it some sort of third-party issue? Is it the browser version that they're running on? All those kind of underlying variables, you kind of answer as long as you have these KPIs to really understand that user journey first, not look at just basic response times or latency on the network or things like that. And so the two concepts we talked about here is that real user data will be the actual performance of your users. You can't really argue with real user browsers nowadays reporting back the latency and performance and experience of your actual visitors. That's something, it's all standardized, it's all, you can agree on it, and it's coming from actual visitors. And whereas synthetic data is going to be that proactive protection and that consistent 24/7 baseline of your performance that you can use to get alerts off of, you can use to basically compare your real user traffic against, and you can use that to make continuous improvements and know exactly how your system or service is getting better. And if you do synthetic in a way where you try to get as close as possible to real user data, you can really combine that kind of synthetic robotic performance data to really see the impact it would have on your real user traffic. And so, performance has a lot of variables involved. That user journey that we talked about before is pretty complex. You have your browser, your versions of your browser, your OS, the continents, regions, networks, providers, pages that people are visiting on. There's a whole ton of variables to consider. So when you're looking at a tool to analyze that data, really make sure that you can ask those questions on how is my performance by this browser, by this version, by this network, by this region, and not be limited to a set of predefined views initially. So kind of the idea of asking questions on that data and make sure that data is accurate and of high quality is really important. Because if you think about this, you're going to use this type of end user data to make informed decisions on, should we invest in a new CDN in that area? Should we invest in maybe a backup DNS provider because we're seeing DNS latency causing first paint and interactive issues on our site? Or perhaps we need to roll back that code that we pushed out and we thought we tested pretty well, but we have to roll it back and maybe refactor what we're thinking about in terms of delivering that new feature or function to the product. So having accurate data and quality data is really important. These are really important decisions you're making about the future of your application and system. But also, if you think about it, the analytics and visualization of that data is almost equally as important. If you showed someone a number that says, hey, we load in 5 seconds on average, and then you show them a line chart, they're going to say, hey, that's pretty useful information, but they may not know what it actually means to load, for example. So things like film strips and screenshots and other data visualizations are going to really get that kind of point home, especially as you communicate to different stakeholders, different user groups, and things like that, because they have to make their own decisions on how to allocate budget, how to productize different features and kind of change priority when you're developing and things like that. So making sure you have the right platform to analyze and visualize that data is also going to be really impactful for how you make use of this type of performance information. And then a really key thing with performance, averages can be very misleading. So let's kind of go through a quick example here, right? So we can all agree that each data set we have here is pretty unique. You have a nice dinosaur data set. You have a nice circle, bullseye, horizontal lines, stars, things like that. And you can imagine that these are data sets that are coming in from actual visitors to your site or service. They will never look like a dinosaur. But the idea is that you can, at first glance, see that there's some sort of delta here or change in this data. Whatever I tell you that each data set here has the same X average in the X direction, same average in the Y direction, same standard deviation in the X direction, and same standard deviation in the Y correction. So if you're purely looking at numbers like means, standard deviation, and things of that nature, you're kind of missing the point of the fact that underneath all that, there is some sort of pattern in that data that you may not know about, right? Your star could be completely different than your dinosaur, so to speak. And so the idea is that in performance, especially in monitoring end user performance, raw data really matters because you can make some really powerful conclusions that you may be completely incorrect if you rely on just a calculation or some sort of high-level view of that data, unless you have that raw data to look at and really understand these underlying patterns in the data, right? And so kind of walking through a bit of an example here, if I said, hey, my site on average loads in 9 seconds, for our industry, that's pretty good. We compare and contrast against our competitors, but you have no idea what that actually means to your users, right? So the idea of histograms are really important in performance analysis, where you can say, hey, that average or that mean is basically right here, but we have a lot of traffic that's faster than that. We have a whole lot of traffic that's slower than that. And that 9 seconds does not actually mean anything to any users. In fact, your average speed or page load time, you could actually have an example where no traffic is actually at that average, and you have two very divergent or bimodal peaks in your data, right? And so even things like time series, they can say, hey, yeah, we have an average of our page load time. We see a spike here, but you don't really know how many people are really slow, how many people are really fast, for example. And so underneath that, taking the kind of histogram view and looking at it in terms of heat maps, will really kind of tell you where a lot of your traffic tends to lie over time. And that when there's a spike, you can say, hey, actually, all of our users had a poor performance in this page load time, or maybe perhaps only a certain subset over that time, right? So data visualization, having tools that can kind of bucket this data and not look at just numbers or trends, but actually the underlying distribution and behavior of that performance data can be really impactful. And it can really help you understand your performance, not just report on it to have a number for it, for example. And so the idea of reliability is kind of the hardest part, in my opinion, is the idea of making sure it's consistent, your availability, your reachability, and performance. Because if you think about it, user reliability, the actual thing you're delivering to your site for your user base, is basically an emergent property of many unrelated independent systems. If I visit a site or service and they have a missing widget on the page, that's an unreliable service, even though everything else on the page can be completely reliable or available, right? So for a user base, don't define your own reliability. Your users have to define that reliability for you. And you think about it, if you have a reliability component that you're analyzing that's been determined by your user base, then you're basically having really good customer success because you're making sure that the users accessing your service are happy in a way that you can actually measure and monitor. And you're not kind of doing it the other way around where you say, hey, it doesn't really matter. Our site's up and available 99.9% of the time, but for that particular user, it was down 2 hours during the day, for example. So really listen to your user base and have them tell you what the site and service reliability should be, and then work backwards from there. And so the idea here is that long-term trends also matter quite a bit, especially with the metrics that we talked about and dimensions of the data that we talked about. So to kind of show you a quick example of that, let me show you this data set here. This is actually some data. We're doing a Google search, right? The idea is like, hey, Google's been pretty consistent in how long it takes to deliver all the things when you do a Google search, for example. You can say, hey, actually, they're pretty reliable. They're pretty consistent. And if I were to tell you that this is basically a month's worth of data here, you think, wow, Google's doing a really interesting job in keeping their search times pretty consistent, right? But then think about the long-term trend of this, right? If I were to tell you that, let's zoom out a bit and look at about a year's worth of data, what you start to see is that there's actually a long bit of a delta here in terms of how long it takes that search to run in Google, for example. And that actual data set I was showing you before was just November right here. And if you actually look at it and say, hey, show me this trend over a full year, you kind of start to see that they actually got a bit slower in October and November, and then they improved it and actually got better in January, February, and March, for example. So the idea of long-term trends matter and having that data quality behind it to really ask and see over this type of long time frame will be really impactful. Because if you just looked at the very small windows of data as they come in, or let's say even over a month's time, you're going to miss those long-term reliability concerns. It could actually impact your business and make it really hard for users to trust your system overall. And so the hard part here is that you need a monitoring methodology and you need people and processes in place that have the rigor of a data scientist. You need to be able to take a long-term trend, separate out by things that you want to separate it out, maybe by region or country or ISP, but also be able to ask questions on that data that you may not know about as well. So the idea of observability comes into play here, where as you get this data coming in from real users and synthetic, you have to be able to ask questions of that data, the ones that you can think of, and ones that you can't think of. And so the kind of idea here is when you have a monitoring system in place, just make sure that you can leverage it in ways that you can't think of, which is kind of a really catch-22, like how do I know what to think of? So really kind of ask the data, think about data quality, data integrity, and make sure you can ask the right questions so you're not being misled by some sort of tool or making poor decisions off of it, for example. And so here's a quick example in action. At Catchpoint, we actually kind of drink our own champagne, so to speak, and we actually monitor all of our SaaS tools that we leverage. So we're kind of an O365 shop. And what you kind of start to see here is we have a trend. Say, hey, there's a bit of a dip in availability for some O365 tools like SharePoint, Outlook, OneDrive, for example, and even a spike in performance during that time frame, right? This is an actual example that impacted some of my colleagues, for example. And we even says, hey, like this performance spike here, you can actually see it was only happening for a certain subset of values. And there were some performance ranges that were actually pretty consistent with where it has been over time, right? They kind of give a heat map. And what's really important is that we can actually you want to ask questions on that data, right? And so what we did is say, hey, let's ask and see if it's actually localized to a particular region or office or city, right? And so again, you kind of see we have that raw data, that scatter plot. We say, hey, this actually looks like it's just happening from New York, for example, as opposed to where I'm based in Boston or my colleagues in Bangalore, for example. And there's some sort of very localized issue here accessing O365 from New York, right? So you kind of have some hints of a problem here, right? It's happening in New York, it's O365. But then you want to see what does it actually mean for this to be slow for my colleagues and what the customers we work with. And what you start to see is that, hey, actually it means nothing's being displayed on the screen. And there's a very long wait time of things actually rendering on the page, with even things like high interactive times. So you kind of have a sense now of, yeah, this actually is impacting actual people. This is actually how a user would feel the site to be slow. And there's some really kind of issue going on here that, we should probably take a look at and try to see if we can improve and talk to Microsoft about, right? And so the idea, again, of analytics and visualization matter. So, we're a bit of a small company, but we have about 250 employees, but we use maybe over 100 SaaS apps across engineering and product and sales and all these tools. So we actually monitor all those systems. And what you start to see is that, hey, there's actually something happening where everything from the perspective of New York in our office was seeing a spike in performance. And then you kind of start to say, hey, it's something in New York. It seems to be impacting a bunch of different tools that we're monitoring. But what you start to see here is that, hey, there's some sort of network component that's different between the failures and the successes. So in our New York office, we have a main ISP pilot, and we have a backup ISP provider, AT&T, for example. You kind of get a real sense here that, hey, when traffic went through AT&T for just a quick moment, everything kind of got poor performance, right? And all of a sudden, there's some sort of issues going on here. So you get a sense, hey, there's some sort of network issue going on here that's impacting the user and the user experience. And so as we kind of drill down further, say, hey, I know network data is usually best visualized when you have some sort of path or flow analysis. You actually kind of start to see, hey, when traffic went through pilot on the way through other providers to reach Microsoft, for example, there was no packet loss. But when it went through AT&T, you see packets being dropped, you see high round trip times. So you have a sense of flow and how networks work that kind of power all of the applications that are running on top of it, for example. And so even kind of taking that further and saying, hey, that time frame where we saw an issue for users, can we guarantee that during that exact time window, we were always on AT&T? This is where things like time series and, again, that raw data comes in to say, yeah, actually here on the third hop of the network path trying to reach Microsoft, you see a very sudden shift where we use Pilot for one provider. There's a performance value on the network side, and then we switch to AT&T, and we were using different performance, right? And basically, the idea here is that the actual story is that we had to switch over because they were switching the cable in our local office because they had to basically upgrade it for purposes, and we had to switch over to a backover provider. This actually really impacted people during that time frame. As you start to see, like, hey, were actual people impacted by this? So this is the real user component. And what you start to see is that we actually have basically understanding from each user in our offices and our endpoints, what's the actual traffic coming into O365 from our offices, right? And so you kind of start to see this actually during that same time frame, all traffic actually died off trying to reach O365. So if you think about what that means, if you're relying purely on real user data to report the issue, you would have no traffic coming in because you kind of see it just stops here and then basically starts up right back here, right? So the idea is that synthetic data was the only way to actually catch this issue that could have impacted users. But you can also use real user data to answer network problems and things like that. So we actually were able to show right at that time that the AT&T switch over, everyone was going through Pilot, but then no traffic was coming in until we got through that kind of upgrade, that quick upgrade they had to do. And so then you can take this further. Let's say some individual was complaining or something like that. You can look down their individual device, the actual applications, what pages and systems they're visiting, for example. And kind of the idea here is that when you're monitoring it in production, sometimes you need to see that high-level approach, everything, the overall uptime and performance across your entire user base. But sometimes you have to actually go down and say, hey, someone's complaining, let me take a look at their individual session, their individual data, to see just exactly how their experience was, right? And so that's kind of the idea of what this stuff does in action, combining real user and synthetic. And I hope you kind of get a general sense here. I'm happy to answer any questions, talk through any different scenarios. I've been at Catchpoint for quite a while, so any tools or ideas you have around monitoring in general, I'm happy to help, and I appreciate your time.
There we go. Oh, I was muted in the wrong place. Sorry. I've been rambling for ages. Thank you so much for that.
Oh, you're welcome.
And that was a great overview of loads of different kinds of monitoring. So we're not done with you yet. We have I have some questions for you, and also we'll be taking questions from the viewers. So if any of the viewers have any questions, please post them in the chat. We have about 20 minutes left for taking questions. So the first one for me that springs to mind is that you're going through a whole load of very impressive monitoring and statistics, and actually the thing I see in the chat, my colleague Dawn is actually asking the same thing, which is that somebody who is new to this and looking at all these incredibly impressive graphs and things and all the different things you're monitoring, it seems incredibly daunting to set up for beginners. So if somebody's kind of getting started with monitoring on their own systems or trying to improve, where should you start? Where's the best value there?
Yeah, that's a great point. So let me go back here, just those 4 pillars. So the easiest place to start is with availability. That's basically, as we were kind of discussing, are you up and available? And a lot of times that's where you have these health checks. You have these very simple components to say, is this app up and running and available? And then from there, you can work towards reachability, which is basically driving either synthetic traffic or understanding that real user data we talked about. And that can also be fairly simple as long as you understand what you want to monitor. So a lot of times with external synthetics, you want to think about uptime or reachability uptime, right? Monitoring from as many places as possible, from as many locations as possible, as frequently as you can. And then kind of letting that data define baselines for you, and then using that to basically improve your strategy over time. So what we tend to recommend a lot of times is you start with availability and reachability, and then you use that information and kind of build on it to say, okay, we have a good baseline of how users actually think our uptime and reachability is. Can we now use that data to talk about performance? And that's where a lot of people kind of mature, and it's kind of the idea of monitoring maturity comes into place, where you can start asking some really powerful questions on, is my performance getting faster or slower than it has been the past day, past week? What sort of KPIs should we look for that really indicate user performance and availability? And one really kind of simple thing to do is if you rely on RUM at first, it's a pretty simple way. RUM has matured a lot where it's actually fairly simple to get some sort of instrumentation into your web apps and your clients. And so that's a fairly easy way to get some data in, and you kind of have that traffic come in, and then you can use that information to inform what you should do from a synthetic angle to say, hey, where should we actually protect are performance and availability. So kind of let your users tell you what to do first, and then have the monitors behind it built off of your user base is a really good way to start.
Right. So for setting up real user monitoring, is it the kind of thing where you basically include a script tag in your front end somewhere, and the monitoring system will already start just grabbing a whole ton of data just from that script tag?
Yep, exactly. And the idea is that most modern browsers, actually all modern browsers support the APIs for this, the resource timing, navigation timing, user timing APIs. And so that data is highly accessible. There's a lot of great libraries out there to access the information. And then the harder part with the RUM piece is not the data capturing. It's making sure you have a system behind it to query, analyze, and store that data in the kind of ways we talked about with raw data, analytics, those questions you can or can't answer at that time. That's usually where people tend to reach out and say, hey, is there some system out there that has been doing this and can do this for us in that case?
Right. Exactly. And that's what Catchpoint does, as with other systems, is gather all the data and present interesting ways of analyzing, querying, displaying. Yep. That's fantastic. So we talked about that's standard in web browsers. How about for mobile apps?
Yeah, it's a great point. So with mobile apps and kind of those or thicker clients or native environments, you can't really have a standard web technology that's going to basically send you data like you would in a normal web browser. So with real user, you have to be really consistent and concise on what you want to monitor. So a lot of times, the best way to start is have your developers, as they develop these apps, really think about these kind of things that you want to measure and set up, right? So you can basically develop your own libraries that will make sure in your app and in your code that you have some sort of custom timers that you built in. And if you do it the right way, you can actually do it in a way that doesn't add much overhead to those native apps. And again, like old Android devices can be very resource constraints and you have low memory and CPU. So if you do a very focused approach as you develop these applications, to kind of think about some sort of telemetry and systems, you can kind of get that data coming in just like you would for real user browsers, the RUM data in browsers. But then also, a lot of times what we see nowadays with native apps, it's not the app itself, as long as you have enough powerful resource or endpoint to actually run that app. A lot of times it's the APIs and underlying services that it's calling that can cause the delays and cause those spinning wheels that cause issues on the app. So kind of understanding how your app actually communicates to your backend, communicates to your content delivery networks, all those API functionalities. If you can replicate those in a synthetic manner, that can be really impactful and really help you understand, are the APIs that this app relies on actually fast, reliable, and quick enough for what we need to do?
Great. Yeah. Okay, so I mean it sounds like it still sounds like more work than with the browser, but do you have? I mean, are there existing libraries out there for native mobile apps that make it considerably easier to and just kind of grab a whole ton of metrics for you? I assume you need to wire them in more places.
Yeah,
but
a lot of libraries have it. I know Swift and I think Java, you can get timers built in and stuff like that very simply. As long as you kind of think about what you want to monitor. For a developer, if they can build the app, they can build some sort of very simple timer into that app fairly quickly.
Cool. Yeah. Not that hard. So with LaunchDarkly, one of the things that the reason that we talk of the name of this meetup is test in production is because we like to be able to partition for new releases incredibly small testing audience, usually QA, and then do a canary rollout, which is a small percentage of real site users. So how would you go about limiting the analysis or the monitoring, or differentiating in the monitoring between those getting the new version and those getting the previous existing version?
Yeah, that's a great question. So the idea of end user monitoring, as you know, there's a lot of factors that we talk about: OS, region, country, time of day, devices people access it on. And those are a lot of factors that real user technologies can capture automatically just by doing an IP lookup through like a database like MaxMind or something like that. But then you want to start to think about, how can I when you do all these canary rollouts and releases, is there some sort of way in like a response header in some sort of JavaScript variable or flag or system that I can actually tell in the client side if I'm on that canary version or if I'm on that newer version? And can my RUM system pick that up and query by that? So the idea is just basically just simply passing some sort of feature flag that's available on the client side that your RUM library can kind of intercept and grab.
Right.
And then filter by that type of trace ID or A/B kind of variable testing or canary flag, for example, and just have that data filtered to that particular value. And then all the underlying components will help you answer, am I fast? Am I slow? Right. Is there any change in my paint times, my render times, my interactive times, all those kind of natures? And then also take that and also apply it to your synthetic data, because the synthetic data is going to be basically a robot that's doing the same thing 24/7. And if there's a big change in that robotic traffic, you're going to know that perhaps some users are actually going to be really impacted because that robot's impacted. So there's a much more likely chance.
Yeah, that's vital to set up as well. When you're doing this, if you do have feature flags or some kind of flag targeting going on, so that you're differentiating between different versions, you want to make sure that you have synthetic coverage for both versions.
Yep.
Going on at the same time, which is kind of easy to forget. Well, when you're doing that, when you're setting that up, and can probably make things more confusing if you're not aware of it.
Yeah, and actually, what we see a lot of times, it is easy to forget, but there are ways. We have continuous testing, continuous integration, pipelines for development. A lot of people nowadays are actually asking, can we control your synthetics or real user via an API technology or some sort of integration piece? Where as we build new things, can we have the monitors built to actually match what we're building, right? And so automation is a big piece here. I think of as you develop and test that you're automating those checks, maybe automate the monitoring you're doing as you push it out to production as well.
Yeah, it's about updating your definition of done, really, for any new feature. It's having the synthetic monitoring in there as part of the usual set of tests and all the processes you would normally do when rolling something out. But I suppose the good thing is that while that piles on, it does mean that it can sound like a lot of work to get something out the door, but that's balanced by all the work you later don't have to do suddenly to fix things that suddenly come up out of nowhere.
Yep. And it's a great way for the IT org in general to support the business going forward and kind of be another, not just a cost center, but also a enabler of customer success and more profits and more revenue and better experience for customers overall. So.
Absolutely. I mean, that's it helps to have, be able to demonstrate that in terms of, that's actually a good question in terms of how do you display it in the cost center, because normally it's hard to evaluate the costs of problems that you don't have.
Yeah.
How do you tend to do that? Is it kind of look at an industry average and then say, look at the difference, or are there other ways that you recommend for trying to evaluate cost savings?
That's a great question. So the idea is that no system that you build is ever going to be 100% reliable. It's ever going to be 100% reachable or available or things like that nature. So just knowing that the things you build, once you put them out in the wild, there are going to be edge cases that you don't know of. There are going to be things that you can't explain when you have, that you actually build in production and things like that. So just knowing that and knowing that that's why you monitor it, because you want to find the things that you don't know about that are impacting your users. In a very simple sense, that's almost enough ROI in that case, right? Is to say, hey, we know we're building the system. The system brings in revenue, whether it's through ads or you're purchasing something or someone's paying you a subscription to access your service. We need to protect that money for the business. And to do that, we have to make sure that any type of monitoring we do with that kind of follows these four things of, can we ask questions on the data that we know about, that we don't know about? Can we trust the data? Can we report on it and visualize it in a way that stakeholders in the business can understand, but also that our customer support teams can communicate effectively to our customer base on. So
right.
Yep.
Yeah.
That whole kind of journey, that kind of wheel of like developing, testing, monitoring, customer building features is kind of how you kind of propel this to really impact your business and say, hey, this is actually something that's worth it and will actually make us a leader in our space going forward.
Yeah. Especially what you're talking about in terms of the conversation between customer service and customers. If you've got, as there's one of the really interesting things that came out of your talk is showing that the customer service teams can have direct access to what that particular user is experiencing.
Yeah.
That you can see the highs and lows of their connection. As you said, reachability, the internet is a long chain of requests and hops, and the weakest link in there is the one that is usually causing the problems. So being able to identify what that is makes a huge difference. Too often been on. I think many of us started in customer service. I certainly did for ISP, and being clueless when going, I know it's working for me, it's not working for you. We're going through all your settings, can't tell what's happening. Everything that you can do to make that more certain and provide more information to a customer service rep translates directly to increased customer satisfaction.
Exactly.
Which is great. So we talked about edge cases, and my favorite topic with this kind of thing is always what are the most interesting bugs? What are the weirdest bugs? What's some of the strangest stuff that you've seen in working on this?
Yeah, that's a great question. So let me actually bring up an example here that we tend to talk a lot about. Let's see. So a lot of companies today, rely on the idea of a content delivery network to essentially get your content closer to the user to improve performance, reduce, make your attack surface for DDoS attacks, lower and things like that, and also just take load off of your origins and things like that. So a lot of times those systems are great; they're built for what you work for, but in certain markets and areas, they perform completely different depending on where a user comes from. Again, where you stand in the internet kind of view depends on how you view it. So a lot of things that we help people understand is kind of is my CDN provider mapping us as we expect, for example? And so there's a lot of work being done in this place from each of the CDN providers to say, hey, are we actually delivering traffic as we expect to? Because that's how we get held accountable for our SLAs for them, right? So let's take a kind of a look here and see, hey, from Boston on AT&T, Akamai, a popular CDN provider, can actually say serve your users from Ashburn, Virginia, from Billerica, Mass, from New York City, from Pittsburgh, from Somerville. And a lot of times you're kind of clueless from this if you look at just RUM data or look at just the data that's running in your data center. You can start to see, hey, actually, most of the time they serve users from New York or from Billerica, for example. At times when the time to first byte's very high, you can say, hey, actually, wow, at one time they went to Pittsburgh, a user had a very bad experience, would have a very bad experience because the network round trip times are high and stuff of that nature. And what's really powerful is as customers start to see this type of thing, you start to think about, maybe I should have multiple CDNs. Maybe I should try to steer traffic to a POP or a region or a provider, depending on conditions that we get from our real user monitoring or from our synthetic monitoring, right? And so you kind of start to see, Cloudflare only has one POP. Is that an advantage? Is that a disadvantage? Does that improve performance? Does that improve your network round trip times, for example? Or perhaps, CloudFront or other providers out there, are there ways for them to kind of understand how these systems work? Because again, the internet's a very distributed place. And a lot of things that people think about is that I'm relying on a CDN to distribute my content. Is it actually effectively mapping it to my user base? And can I actually relate that back to the user traffic I'm seeing out there in my real user traffic and my other analytics that have on the site? So it's something that we tend to see quite a bit. And it's not a question of which provider is better than others. It's more about what's the best for our business and to guarantee the performance and reliability that we need for our users. Did I lose you, Yaz?
Hey, this is Kim. Yeah, I think we lost Yaz for a second there.
Sure.
Hopefully he'll be back in a moment. We'll give him 30 seconds.
Sure. And I actually do have another example I'll bring up. A lot of times, since we're all kind of working from home remotely, we've been really stressing like being on time for meetings and things like that. So in my role, I join a lot of meetings and I want to make sure I'm on time. But about a week ago, I was seeing that my clock in my local Mac was actually about 2 or 3 minutes slow. I was like, that's very strange. I was actually joining meetings 2 or 3 minutes slower than my colleagues and the people I talk to on a day-to-day basis. That wasn't too big of a hiccup. It was just kind of an eye-opening. And so knowing that and knowing that time is based not off of HTTP traffic, it's not based off of DNS traffic or things of that nature. It's its own protocol, the NTP protocol, one of the oldest protocols in the web, actually. The idea is that synthetics can actually apply to more than just your web traffic or your API traffic. It can actually apply to things like your server time that you rely on to sync your servers, or in this case, sync my PC so I can join meetings on time. And so kind of fun example here is I was like, hey, I'm a monitoring person. I'm kind of a geek in this thing. So kind of catch point towards time.apple.com and measure the round trip times to those from different cities around the US. But also measure what's the offset that synthetic probes are seeing from what the kind of route time is at time.apple.com. When I saw during that time window, I was like, hey, from Boston, there's a bigger offset for the synthetic agent as opposed to from Vegas or Chicago or Miami or Philadelphia. And so It's like, hey, now I know, for example, that the time protocol I relied on in this case was maybe having some sort of issues in the Boston region, and I could actually investigate and look at, is it the network? Is it some sort of local environment, right? So this is kind of some fun edge cases that once you think about how the internet works, can really not only improve my day-to-day to make sure I'm on meetings on time, but also give a general understanding of how you actually deliver for your customer base overall.
Yeah. That's fantastic. My connection disappeared for a couple of minutes there, but thank you for carrying on without me.
Of course.
So one thing I was wondering about that actually is how, for those figures, when it's in the red, does it give you a degree of confidence in like the number of users who are seeing those first time to first byte issues, in terms of, is it just one user who may have been on a poor cell phone connection or something, or is it something actually happening for a large percentage of users, a large number of users?
That's a great point. So the idea of every user is important, but at times you don't want to alert off of maybe just one user having a bad experience. You may want to know about it, be able to drill down into it, but how you operationalize real user data in synthetic data can be really powerful. So what you want to see is, of my overall traffic, my overall user base, is that one condition a very common condition, or is it an outlier that's kind of going on? And that's where those things like those histograms and those heat maps can be really powerful, because you start to see the trend. You start to see the trend of, is my user base kind of shifting right or left in terms of performance? I'll bring it up here real quick. Yep. So you may say, hey, that one user's really kind of poor performance up here. It's in the red, right? But if you start to see more of the traffic start to shift towards that, that's where you start to say, hey, this is actually something that we should really take a look into, because that traffic's being shifted towards that long tail, essentially. And this is where things like alert profiles, alert granularity, having the option to really specify different types of alerts off of different types of metrics can be really critical and kind of really help you get ahead of that. And especially if you're relying on RUM data or APM data or some sort of passive data set, to alert. Basically, you're saying, hey, alert me if 10,000 visitors have this type of experience. That's essentially 10,000 people that you might have made agitated and may not like your service anymore, right? Whereas if you think about synthetic, that's where the protective piece comes in. This is where you can say, hey, for this very important user journey that we have identified in our analytics as being really important to our business, can we proactively get ahead of that and say, if this happens for 2 robots in a 10-minute window from this time to this time, and it's this type of increase in performance, we should actually take a look at that and investigate it. And it may or may not actually impact real people, but it will help you get ahead for most of the time. It will help you get ahead of issues that actually would impact real users.
Yeah, that's vital. Thank you so much. I think, sorry again for disappearing at that time, but thank you so much for carrying on without me. This has been a fantastically helpful look at real user monitoring and synthetic monitoring. I did not know that you could. It was eye-opening to me to see, especially the reachability aspects, the fact that you can show where in their user's journey requests things are going bad is incredibly helpful, and being able to especially partition that according to when you are doing canary rollouts or other kind of targeted deploys is super helpful. So thank you so much for joining us.
You're welcome.
So that's it from us today. Now we've delivered 2 of these. We are making a regular habit of it. So please join us next Thursday at 10 a.m. Pacific time, which is 6 p.m. UTC. Thank you so much, Zach Henderson, for teaching us about front-end monitoring. Zach is the lead senior solution engineer for Catchpoint. My name is Jos Graham, and I wave my hands about feature flagging for LaunchDarkly. Thank you all for watching us. Thank you, Zach, for joining us, and have an excellent week. Farewell.
Take care, everyone. Thank you all.